Are you ready? Yes. Here, I have a stylus. Is it your stylus or is it your computer? Yeah. Mm-hmm. All right, here we go. Parent graphs. That's why, to some extent, it's almost better if you just consistently print these out. I mean, well, hold on. Family of parent graphs. All right, constant function. Y equals a value or X equals a value. So we know that. I'm going to make this a different one. I'll say if X is 4, you need to remember, please, that this is a what kind of a line? If X is equal to, is it horizontal or vertical? Thank you. That makes this one horizontal. All right, what we're looking at today is what is going to happen if we multiply our parent graph, or if we add something to our parent graph. What is it doing to our X and our Y? Because that makes graphing it really so much easier. Once we know in our head, we know what these graphs should look like. So when we start changing things by adding or multiplying or dividing by values, what does that do to our graph and how does it change our look? That's what we're looking at. So we're going to review just what these parent graphs look like. So y equals 3 would be this one. X equals 4 would be this one. And Alex, these finished are already on Moodle. Okay, exactly what I'm doing. All right, the identity function is simply y equals x. And we know that that's this one here. That's your identity. I mean, we can do y equals negative x, but we've learned that y equals negative x is going to be a flip over the y-axis. Okay. All right, polynomial functions. One of them is y equals x squared. This is the parent function because I'm not adding or subtracting or multiplying x squared by anything. It's very clean. There's nothing else there. It's just a y and an x. That's what makes it the parent function. This is the shape of a what? Thank you. Point it up at the origin is the vertex. And so we remember from last year that when we multiply values or add values, we make the parabola wider or narrower. If we multiply or divide, if we add values, we're shifting it up or down or left or right. Okay? So we kind of already know some of these rules. We've just never really expressed them. Okay? All right, so the other polynomial function that you have is y equals x cubed. All right, parent functions we want to assume are always going to be positive. The negative is going to be a flip in some direction. Polynomial function, what axis does it hug? The y-axis. It's one of these with a little point of inflection, and currently that point of inflection occurs at the origin because I'm not adding or subtracting anything to it. Okay? All right, and then what we have are root functions, square root functions in particular. What does it hug? Hugs the x. And so the parent one is y equals square root of x, and it's going to go out like this. This is familiar to you because we talked about it in the first section, correct? Okay, so it's starting to sink in. Absolute value functions, y equals absolute value of x. The parent function looks like this. What we do with it is we're moving that vertex left, right, up, down, making it wider, making it narrower. That's what we could do to that. Greatest integer function is a parent function, y equals greatest integer of x. We know that that's a step function. And so it's solid to open, solid to open, solid to open. Mine's a little off. Mhm. Well, there is no origin. It always starts at the left and opens to the right because you're always going to take that lower integer value. The, so at the origin, start, open. I'm kind of just showing you a basic graph because my stylus is so thick that I'm not able to actually put it on the correct values. All right, the last one is your rational function, y equals 1 over x. Here we have asymptotes on the x and the y-axis, and so when we start adding and subtracting things, those asymptotes are going to shift, okay? And when we start multiplying by things, the wideness and the narrowness of our shape will change also. But currently, the parent function looks like this in quadrants 1 and 3. We know that if it's negative, where would they flip to? 2 and 4. Okay, so what affects the appearance of parent graphs? Well, there are reflections. All right, here's the first one. There are translations. So reflection is, what am I reflecting it over, the x-axis or the y-axis? Those are my two options, okay? Translations, that means movement. Where am I moving my vertex? I'm moving it left, right, and up, down, okay? A dilation is, do I make it wider or do I make it narrower, okay? Vertically versus horizontally. A vertical dilation is going to be affected by an x value. A horizontal one, anyway, you can affect it x or y. And we'll talk about that in a second. So there are three ways that you want to consider this. Okay? So if something is reflected over the x-axis, now, I'm going to give you all this information, and then I'll show you how it applies to all these problems. So just write down what we have, and it'll make sense when we start actually applying them to the problems, okay? If I'm going to reflect it over the x-axis, y equals negative x. I want you to pay attention where I'm putting this negative sign, okay? If it's over the x-axis, I'm changing it, and it's outside, not associated with the x. If it's reflected over the y-axis, then y is equal to changing the sign. Okay? Yes? I'll show you what it looks like. In this case, yes. All I'm doing is placing the negative sign, but you'll see what happens when I give you some functions. Okay? So here it's in with the x, here it's outside. So basically what I'm saying here is if I'm reflecting it over the y-axis, my y value is changing from a positive to a negative. So the y value is changing. Whereas if it's across the y-axis, remember my x value goes from a positive value to a negative. We talked about that yesterday, right? Okay. Translation vertically. Well, this is going to be adding, so I'll say something like f of x is equal to x plus 2. There is my vertical. It's outside. It's affecting your y. So this affects the y. Or I can do f of x is equal to x minus 2, which means I'm going to go down 2 units. This should be completely okay with that. We did this with parabolas, right? We just did these with absolute values. If we add something at the end, we're moving it up and down or up or down depending on what the sign of it is. Now, horizontally, then you've got something like this. F of x is equal to f of x plus 2. Basically, I'm saying it's going to be associated in parentheses with the x. So not outside the parentheses, but inside the parentheses, okay? So just like our vertices on our absolute value, it's the opposite sign, isn't it? Remember, if it's with the x, it's the opposite sign of what's in parentheses. So we think of a movement to the left 2 units. Or if f of x is equal to f of x minus 2, we're saying it's moving it right 2 units. So we think of the opposite sign of what's shown in parentheses. Are we okay with that? Okay, here is where this is new. Dilation. All right, horizontally, if I give you y is equal to 2x, vertically means along the y. Oh, sorry. Sorry. Vertically, notice where the placement is. The placement is really outside of the x, okay, because it's not in parentheses with the x. So this is called an expansion vertically. You got to tell me the direction of 2. So we're looking at this value. It's sitting outside. It's going to take my y value and it's going to raise it 2 units up. It's going to expand it by 2. If I said y is equal to 1/2 x, then you're going to say, because this value is less than 1, I'm going to shrink it, aren't I? So we call it a compression. So looking at this, we're going to say it's a compression, but you need to tell me the direction by 1/2. So if x is 1 on the parent graph, y should be 1, right? But if I put that 1/2 in there, if x is 1, well, y is now, 1/2. So it's compressed the value from with respect, no matter what function. This is a rule for all of them, okay? So horizontally, this is so the general rule for this one is if I give you y equals, I'm going to say c, which is my constant, of f of x. If this c is greater than 1, it's an expansion. And if c is less than 1, so between 0 and 1, it's a compression. That's the basic rule. Now look at where that c is. That c is outside of the function. It's affecting the y, which is why it's vertically. Okay? Can't fall asleep in today's lesson. All right, now we're going to do horizontally. Horizontally means it affects the x. If it affects the x, then everything that you're multiplying is in with the x. Inside with the x. Okay? So if I give you something that says f of x is equal to, see, this is inside with the x. Do you see that? Versus this. Do you see how I'm squaring both the 2 and the x? So whatever's happening to the x is happening to that number. Whereas in this one, I'm going to square the x first, and then I'm going to take that answer and multiply by 2. Do you understand the difference of where this 2 is being placed? Because that's what's going to give you a hard time. Okay? So this is going to be vertical, but this is horizontal. Okay? So if I take my value and I multiply it by 2, this is kind of the opposite, just like a vertical or a horizontal movement is opposite of what's going on. If that 2 is really there, we want to think about it as a compression. Horizontally of 1/2. It's the reciprocal of what's going on. Just like your movement horizontally is always the opposite sign of what's shown inside that parentheses, the compression or expansion is opposite. So 2 looks like it should be an expansion because it's greater than 1, but we want to really write it as a reciprocal and look at it as 1/2. So we're going to say that, oh, sorry. Hold on a second. We're going to say not a compression, it's an expansion. But of 1/2. All right? If I say f of x is equal to 1/2 x squared, then we're going to say we've got a compression of 2. So flip it. Flip the value to tell me which way it's going. Yeah. Let me make sure I have this right. Expanding. Okay, so let's look at the next one. You want to think about it. Yes, Alex? Yes. Only the horizontal. Okay, you want to write this with respect to the parent graph. So the parent graph for this is y equals 1 over x. That's what the parent graph is, because it's a rational function. So what we're doing is we're saying y equals 4 times 1 over x. Is that 4 with the x? So it's affecting the y. So that value is greater than 1. Is it an expansion or a compression? By what value? Expansion of 4. Now you've got to tell me the direction. Vertically, because it's affecting the y. Let me check something. Oh, no. I just want you to tell me what's going on with that. Yeah.
Do you know that it's affecting the y
If
because,
yeah. See, if I wanted it to affect the x, I would have said 1 over 4x. Then that 4 would have been down there with the x. So it would have been a compression, wouldn't it have? Of 4. Okay. All right. Here we go. Well, that's what this is for. One of those are your parent functions. Okay. All right. So this is, let's rewrite this so that we can figure it out. This is negative. What am I going to do? 1/4. Where's that x to the negative 1 go? Down here, right? We're all going to put it all together, right? Plus 3 equals f of x. All right, we got lots of things going on. Isn't 0.25?
oh, that's 0.25.
Mm-hmm. So how do you write x to the negative 1? Remember, how do you simplify a negative exponent? Okay. All right, so let's start with the easy one. Is this negative sign affecting the y or the x? Okay, let's go back and look. Where's my page? Is it down here? Where's my x? Is it out in front or in with the x? Out in front. What's it affecting? Okay. So, that affects the x. If it's sticking out in front, it's affecting your y. If it's in parentheses with the x, it's affecting the x. It would, but the way we wrote it, we want it to affect the y value. Okay? Okay. For example, it'll be really clear when it's with the x. It's not affecting the x versus something out front that would be affecting your y. Okay? All right. So this is gonna give me a what? If it's affecting the x, what's changing? I'm sorry. If it's affecting the y, over which axis are we going? If it's affecting the y, it's flipping over which axis? Okay. So it's a, I'm not going to say a flip. I'm going to say a reflection over the x-axis. Okay, this one's easy too. How am I moving if I'm adding that 3 out to the side? Left, right, or up, down? It's not in parentheses with the x. It's over to the side. So it affects the what? The y. So am I going up, down, or left, right? Which way? Up or down? Because we keep the sign if it affects the y. Think about it in terms of this. Y is equal to x plus 2 squared minus 1. Isn't that always affecting the y, moving it up and down? That's what this is doing out here. It's hanging outside, not with the x in parentheses of some sort. Okay, so that means this is a, what kind of a shift? Horizontal or vertical? So vertical, shift, which way? Up. Yeah, I should say. I have it on here. I just forgot it. Okay, now we got this 4. It's down with the x, right? So we have to think the reciprocal. We're going to look, and it's going to affect the, which one? If it's with the x, is it horizontal or vertical? If it's affecting the x, horizontal or vertical? So this 4, so we want to look at it as 1/4, correct? Remember, it's with the x, we flip it, right? Now, is 1/4 going to be a compression or an expansion? Compression. What value? I mean, which way? If it's with the x, horizontally. What's the matter? Okay, we'll do some more, and I think by the end you'll see it. It's where the placement of that coefficient is. This is your answer. I want to know, with respect to the parent function, which is 1/x, what did all of this do to my graph? It moved my graph 3 units up. It flipped it over the x-axis, and it compressed all of my values by a factor of 1/4. Does that make more sense? You could. If you plug this in onto your graphing calculator and you plugged in the parent, you'd see what was going on. If I did all this stuff to it. Okay. All right, let's try another one. All right, the parent graph is y equals x cubed, right? Now the only thing that's going on in here is that's different is this -1. So you just have to keep asking yourself, what is it affecting? Is that -1, which is in parentheses with the x, affecting your y value or your x value? X value. So if it's affecting my x value, is this going to be, do I think of it as a compression? Do I think of it as a dilation? Do I think about it as a shifting? Do I think about it as a reflection? Which one? Yeah, it's shifting 1 unit to the left or to the right? Left to the left, to the left, right to the right, to the right, left, right, left, left, right, right. Which way? Negative with the x is to the right. Remember, it's the opposite sign. Think of your absolute value functions, your vertex when you had to figure it out. You took the opposite, whatever was with the x, and you kept the sign of what was with the y. Remember? So this is a shift 1 unit. Which way now? Right. Okay? That's it. Everything else, I have no negative signs. I have no multiplication signs. I have nothing being added over here to the side. So that's the only thing that happened in this problem. Allie? The parent graph, again, is just 1 over x. Well, if it's got an x in the denominator, it's 1 over x. If it's cubed, it's x cubed. If it's square rooted, parent is just the square root of x. All the other junk, and just look at the x and what's going on. Is there an exponent or a root or something like that? Allie? I don't understand your question.
Do we apply the parent graph to the equation anywhere, or is it just kind of
No, that's just your parent graph. Now, look at all the junk that happened to that parent graph. Explain to me from the parent graph what I'm going to do if I wanted to graph it.
So you would graph y equals x cubed and then shift it 1 unit to the right.
Yeah, so this is what, no, that's not right. This is my parent graph, right? Right? That means this point of inflection just got moved 1 unit to the right. Is that better? Mm-hmm. Okay.
Is that what you're doing with the 3, like shifting it up?
Yeah. So this one was going to,
So it would just be like on the x or y axis.
so the parent graph for this one looks like, no, that's not.
So it's like 0, 0, 0, and then it would be on like 0, 3.
That's the parent graph, right? That's the parent graph, right? We got to flip it over the x-axis. That means now we're here and here. Okay? We're going to shift it 3 units up. That means we've moved that little dotted line, right? That was in the parent graph, that asymptote 3 units up. We haven't shifted the asymptote that's vertical left or right any, right? Because there's no vertical shifting, correct? Or horizontal. So that one's still there. So basically, we're in here and here, but we've really compressed it. So the values that you would be plotting would be 1/4 of what the original one was.
So the aspect of that is now 3.
Yeah, the horizontal one. The vertical one is still at 0. Is this making more sense? Okay. Have another page? Okay, so let's look at this one. All I did was add a negative sign to what I had going on, right? So this is what? What did we just figure out on the other one? What did this do? This is a shift. Don't tell me right. How about horizontally? 3 units to the right. Thanks. 1. Okay, now, is this a negative sign in with the x? So it's going to affect my x or my y. So if it's making my y go from a positive to a negative, then it is a reflection over which axis? The x-axis. If it makes my y go from positive to negative, it's going over the x-axis. So really, if it's affecting the y, it's the x-axis that you're reflecting over. If it's changing your x, it's reflecting over the y-axis. Okay? So this is a reflection over x-axis. And I'll show you in a second.
What would the parent function be?
This is still cubed. This is y equals x cubed. So the negative sign flips it. So we're, instead of being here and here, we're now here and here, right? And we moved it 1 unit up. No, that's wrong. We moved it 1 unit to the right. So we're doing this. Okay? All right, now, 1 unit, which way? Right or horizontal. I guess if you're going to go right or left, you don't have to say horizontally or vertically. 1 unit right and 3 units up. So now, while the parent graph looks like this, that point of inflection moved 1 unit right and 3 units up. And it's doing that. Yes? Uh-huh. Yeah, I just said you don't have to. If you're moving left and right, you don't have to tell me horizontally, because if left and right is horizontal. So just. It's always, with the x, it's always the opposite sign. When it's with the x, it's the opposite sign. When it's with the y, it's the same. Okay, let's do this one. Okay. Parent function is what? What does it look like? Right, get rid of all the gunk. Just leave yourself with that variable. Okay? This 2, is it with the x or the y? Okay, so go back and look. This is the dilation or compression or expansion. If it's with the x, do I take it as 2 or do I have to flip it? Yes, yes. Okay, so we're looking at it as 1/2, and so we know that this is a horizontal. Is it an expansion or a compression? Compression. Yeah. What one? Right. Because that was what our direction said. When it's with the y, you keep it. So if I had it out here, this would have been an expansion vertically of 2. But if it's with the x inside, you flip it and then look at that value. All right, the rest of these notes, girls, finished notes are on your OneNote, so there's some extra examples that we didn't get through. All right, take a look at the OneNote notes that are all done. Whatever's on Moodle.